Hello, this is a video about using p5.js to sample pixel data from images. I'm making this video for students in my creative coding class who are going to be completing a custom pixel project pretty soon. But before getting into any code or explaining what I'm doing even, I want to give a bit of background and about what a pixel is in order to help us understand what we're trying to do here today. So first of all, when we think about what an image is, there's lots of different ways you can compose an image out of multiple parts. And textile art, needlepoint, weaving, crochet, knitting, these are different ways of using colored fabric to create a way of looking for something, and sometimes that can be used even in a representational way. So Anni Albers was a 20th century textile artist who worked with different media to sometimes create abstract images or sometimes make images like this one, or works like this one, I guess, not even necessarily an image. I think I would call this abstract still, but there's a bit of representational structure here when we look at what this is titled and what it might suggest to us. This is called Northwesterly, and it does have a sense of the Pacific Northwest in terms of its colors and its overall shape, maybe a marshy kind of area. Another work by her that also suggests a sense of place and a perspective, and even a sense of a landscape, perhaps, is this South of the Border from 1958. So these are textiles. These are not pixels in the sense that we would think of them as part of digital graphics, but these are similar units composing something else, representing points of light using a specific media, and then they're all combined in a way that has a matrix-like, brick-like structure, but obviously textiles are going to be much softer than bricks. In a modern context, the artist Scott Blake is someone who works with pixels or different types of pixels to constitute an image, and this is a couple of self-portraits that he did using his project called the Chuck Close filter, which takes an approach that's based on the artist Chuck Close, and Chuck Close was an artist who made very, very large-scale photorealistic images of people, portraits of people, usually using tiled representations that we would recognize as pixels or pixel-like. He wasn't doing this digitally, he's doing this by hand, but the same idea seems to persist here, where he's painting little units of it, and then those units all together, especially as you step back from it, look like a total image. Scott Blake is a contemporary artist who wrote some software to do something similar. I think in this case he actually sliced up paintings by Chuck Close and then reassembled those slices in ways that could represent a specific portrait or image. Scott Blake has quite a lot of other cool stuff on his website, so I definitely recommend checking it out, barcodearts.com. These are just a few samples at kind of smaller scale, but these are portraits composed of ISBN, sometimes barcodes, or other kinds of barcodes that are then presenting an image of a face. Typically, these are portraits. A lot of other cool stuff on his website, and Scott Blake is clearly an artist who does a lot of work with this idea of thinking about what we make images out of in a digital sense. So looking back at the history of computer art, there's a pretty famous early example of this kind of thing. This is Leon Harmon and Knowlton's Study in Perception. It's originally a photo of a nude woman on a couch, but it's composed of elements that are not pixels, but are little tiny typographic, mathematical and technical symbols, and zoomed in you can see those clearly, but zoomed out it still resembles that photograph. This is called Studies in Perception because it's a question. It's studying how do we perceive this, and where does our perception collapse? Where does it stop being a photo of a woman, and where does it start being a matrix of these symbols? And that might be a question of distance, or it might be a question of how you think about it in an ontological sense. So there's a lot of really interesting things at play in this very early work. So Ken Knowlton continued to experiment with this this idea of perception of images composed of different types of things through different media, and this is an example of a poster he did, the United Nations Declaration of Human Rights from 1970. But as you can see, probably even more clearly than I can, this is also a photo of a girl's face. Zoomed in if you can. I don't think I can zoom in the way I've got this set up right now, but if you can read the text here, it's the text of that declaration, but it's done so that where text needs to be a little bit lighter, it's a thinner typeface, and a thinner weight, a lighter weight typeface, where the text needs to be whiter for the girl's face. That's a heavier typeface, but it's a white on black typeface, so it shows up more like her features. And so we see this as a photograph, but it's also readable, it's legible as text at the same time that it's also something we can perceive as an image. There's a lot of cool stuff on Ken Knowlton's website too, and I'll link to all these websites and resources in the description down here. But Ken Knowlton has made quite a few pieces that were not digital works, but this is an example of a really just, I love this piece. So it's called This Is Not a Teapot, and it's a mosaic of a teapot made up of fragments of a teapot. And there's a lot of interesting, there's like two references I think in the title. I think it's referencing a painting by Magritte. It's also representing or referencing a common example of digital graphics, the teapot demonstration. So there's a couple of interesting things going on with this, but also it's just a fascinating piece. So that's a little bit of background. Next, I'm going to talk about what a pixel sampling program is actually going to do and then I'll eventually show you how you might be able to use it to create a custom pixel project. Actually, before getting into a demo of what I'm going to be doing, I want to mention a couple of sources that I've consulted and used in the demo I'm about to produce. This is a project called Pixelator by Andrew Sink. I found this on YouTube, and this is an interactive version of what I'm going to be doing. And you can see it here. If you move left to right, it gets more and more pixely, it gets less and less pixely going that way. And this is relying on pixel sampling and then doing something with that sample that makes it look more, mosaic-like as you move left and right. And then in the source code for Andrew Sink's project, he references this example by Dan Shiffman, which is doing something with a mirror. This doesn't seem to be working, at least in this browser view, but I believe the idea was that this would take webcam imagery and do something similar to it. Okay, so here's what I'm going to talk about next. This is over here, this is a photograph of Abraham Lincoln, and I wanted to demonstrate what I'm talking about when I say pixel sampling. So this is a photograph that already exists, and what I want to be able to work with in order to make a representation of this is the pixel data at different points throughout this photograph. And if you've ever done anything with digital art, like in Photoshop or GIMP or other things, there's usually some kind of eyedropper tool that you can use to figure out, okay, what color is this particular pixel? I mean, we're used to thinking of images as composed of a matrix or a raster of pixels, and sometimes we want to know what color is that exact pixel, and we can kind of pull it in here. So that's basically what I'm doing here. So I wanted to just kind of provide a way to conceptualize that. So when we talk about pixel sampling, I'm talking about putting a bunch of like imaginary eyedroppers in a kind of grid that moves back and forth across this and picks up the pixels at different points and then remembers where that pixel was that it picked up. So this isn't going to visit every pixel necessarily. I mean, you could make it do that, but it's going to visit whichever pixels we want. And in the code I'm about to use, I've got a couple of variables. So I'll show you how that would look here in this view if I change these variables. I'm calling these sample X and sample Y, and these are the space that the virtual eyedropper moves left to right as it picks up a pixel. So it starts up at 0, 0, then it moves right by pixel sample X, and then down by sample Y over time. So it's going to build it up this way. In this example, this is 20 by 20. So this is a sample size of 20 by 20, which isn't picking up every pixel within that square, but it's picking 1 pixel per every 20 moving left, and then 1 pixel every 20 going down. And so if that's a little bit hard to visualize, let me show you if we move that to a larger sample size. I better make that big enough to actually see. And then here we go. So now this is picking up every 120 pixels. So this would be if I were to make an image out of this, you might call this a much lower resolution image, but it's a much lower sampling rate is I think a more accurate way of describing it. So hopefully you can see that okay, and hopefully that helps. Let me just show you if I made that a very high, very dense. It was originally 20, I think. So let me show you what it would look like at 5. So sample 5, and then see how that looks here. So obviously that's, it's covering up Abraham Lincoln in eyedroppers. So this would be pretty close to the original, but if I wanted to get the original, I'd have to sample it at every pixel one by one at a time, and that would actually take quite a lot of memory. So I'm not going to do that right now, but hopefully this helps. I meant this just as a demonstration of what I'm about to show you how to code if you want to work on this project. So yeah, that's the eyedropper demonstration, and I'll share this example code in my description as well. Okay, I think I'm ready to do some coding. I'm going to keep this kind of loose and move through this quickly-ish. I don't know if you're trying to follow along, you can always pause things or play it back, and of course if you're in my class you can ask questions in our Discord server. So what I've got set up here basically over on the far left, your left, I've got some code that I'm going to work on. It's the blank sketch that I'm about to start adding to. This is just your standard starting point for a p5.js sketch, and then sort of up above me and around me there's the sketch, the canvas that's going to be generated by this sketch, and there's obviously nothing there yet. Any of these things can be changed or done slightly differently, I'm sure, but I want to just kind of build up a working example where I'm going to load an image, then I'm going to write some code that's going to sample that image at different points, and then your job, if you're a student in this class, is going to be to try to do something interesting with those samples once you've got them. So I'm going to take you up to that point with this tutorial, and then it'll be up to you to figure out how to do something interesting with that. I mean, I've got some ideas, but I'm not going to go into them today because I want you to show me your ideas. I don't want to preclude any of your ideas. So first of all, the p5.js has, of course, the setup and the draw function, which we've been using a bit. We haven't used draw that much, but we will be using it. But there are several other kind of preloaded, available functions that you can use. The one that we're going to need to do to access an image is going to be preload. So go ahead and add that before your setup function. It is important to do it before because pre, as the name suggests, is something that's supposed to happen beforehand. And what I'm going to do is create a variable. We'll call it image. So just let img, and I'm going to load a image file into that variable. And what I mean by that is I'm going to actually like pull it off of the web and then load it in that way. So let me see, I need to find should pull this up beforehand, but I'm going to find the URL of an image I want to work on. And I'm not going to even show you what the image is, but I will, maybe you can guess based on when you see the URL for it. So I'm going to be pulling this off of the web. You can actually load an image. If you're doing this on the web, like using the p5.js web editor, you can actually load an image, upload an image into the folder that you're working on there. Since we've been working mostly on your local computer, and for security reasons, you can't let a JavaScript file access a file on your local file system. So I recommend doing it this way, where I'm going to pull a URL from my GitHub repository that I've already uploaded there. And so you can kind of see it here. Let me see. I'm actually going to go ahead and do the wrap layout here so I don't have to keep scrolling back and forth. So this is still line 5, right? But it's just wrapped down here so I can see the whole thing. And so this is all it is. So image, load image, and now this image is now available in memory. And if I were going to just draw this image onto the screen, I could do that now. And that's a pretty straightforward thing. And I guess I will end up showing you the image here, which is to say I need to now that I have this file called img, let's say in this variable called img, I can use it using the image function. The image function is similar to some of the other drawing functions. It's called image though, and you have to give it a variable name of an image to load here, and then you tell it where to load it. It's kind of like the circle or the square functions. You say, okay, here's the circle I want, and here's where I want it. And if I save that, I should be able to go over here and refresh and see this image loading. And yeah, there it is. So it's a painting of Optimus Prime. I generated this with DALL-E 2, so that's what that is. And for an image, when you're doing this, you can, so the img is the location of the image, and then 0, 0, that's the location on the canvas. Of course, you could use translate to move things around if you want to. I do kind of like doing that, so just go ahead and push that off the side to put it more like in the middle, and so it, pretty close to the middle there. So that kind of looks nice, I suppose. But that's the image that I'm going to be working with here, and that's how I would do this if I just wanted to load an image. Of course, I don't want to do that, but that's how it would work. So I'm going to go ahead and comment that out, just leaving it there in case I need it for some reason, just to double check what I'm doing. Okay, so the cool thing about pixel data in p5.js is that it's available as a very large array if you want it, if you need it for some reason. In order to get it, though, you have to actually tell p5.js to load this data as that array. And that's something you do with the load pixels function. So it's a function that's attached to a image object, which is something we haven't covered yet, but objects are a special kind of thing in code. And that's what the img actually is. It's not just the name of that file, it's actually the data of that file and a bunch of other stuff called an object, and it's a special kind of object called an image object, and in this case it includes lots of things like a function called load pixels, which will automatically go through that array of data, all of those pixels for that image, and then load them into a informational array that we can then inspect and use and work with here in our code here in a minute. So you have to actually call that first before that information is available. So I'm doing that here in setup, and then that should mean that it's available now once I go over here to my code. So I'm going to use it here in a bit, but just to double check that it's there, I can open up the browser console and just call it by name and see if it's there. So if typed, I don't know if, I guess you can't see this. Let me drop that up here for a second. So the browser console can be a really useful way to find out about the structure of something before you even start using it. And what I've done here is I've just typed the name img, that's the variable that I created, and this just kind of gives me a sense of everything that the browser knows about that object, which is quite a lot. And it does include things like the pixels in them. So the pixels are actually this very, very long array right here of information. It is an array, so an array is a list basically, and it's a two-dimensional array, so it's an array of arrays, a list of lists. This image is 512 by 512, so the number of pixels in it is I guess that 512 by 512 is that what that is? We can always do the math in the console, right? Let's see, 512. So yeah, so it's going to be 262,144 pixels. Each of those pixels is represented as a list, and a list that contains 3 items in it. So let me show you what one of those looks like. To pull up any item in a list, you have to use the square brackets to slice the list and show you that whatever information is stored at that index position. So let's say, so it's image, and so let's say I wanted to see pixel number, I don't know, 1,859. And so, actually, nope, sorry, not the image. I have to actually use the pixels method to get to that. So, sorry, I messed that up. So it's actually 157. So, yeah, so that's interesting. So let's see. I don't know if we could find that in here. It's in here somewhere. It doesn't really matter. So it's in there somewhere. But the point is that that's some information related to one of the colors of that pixel once we pull that out there. Once we find a way to pull it out, basically. All right. So like I said, I'm going to now write some code that's going to move around through this image and hopefully report that information, kind of one thing at a time, kind of going into it. So. All right, so let's see. And this is the part, like I said, I got some code from the Andrew Sink example, who got some code from Dan Shiffman. Oops, let me put myself back on top, put my code back up there. Okay, so this is my code, and what I want to do next is make a couple of for loops. This is something that we've done several times already in the class for different reasons. Let me just make this a bit wider, and so I can see it more clearly. And this is a for loop, so right, so we'll do 2 of these. We'll do a X loop and a Y loop. That makes sense to me. Actually, before that, you know what? Before even doing that, let me go back to, remember my eyedropper example. I had the idea of a sample X and a sample Y, and this is going to be my how far to move value, like how far to move that eyedropper as we go throughout the, as we move our way through the image. So let's take a look at how we can use that here to make that work in a for loop. So this is something we need in a for loop. So I'm declaring these variables at the outset. I'm going to go ahead and set them to 50. This can always be changed later, as you saw me doing earlier, but this is going to be something that will help save us a little bit of time if we do this first. So, okay, now a couple of for loops. For, and we'll say let x equals 0. So we're going to use x and y as we move through this. So we'll start at x. We're going to go x is going to continue increasing, and we'll get to that increase in a moment, but it's going to continue increasing until it reaches the value of the width of the image, and that's a special value that's stored already in the image object. So image.width accesses that number. If I go back over here to my, oops, I keep disappearing. Back to my browser. Nope. There I am. So if you go back here to the console, you can actually see that. If you just want to know what is the image width, it'll tell you 512. So the code already knows what the width is. I know it too because I made the image, but you don't have to know it in order for the code to be able to use it. So image.width will be the width of that, and then we want x to increase by a rate of sample x, because that's the value that I'm going to be sampling at. Okay, so this is a function, a loop, so I'm going to do the block here, curly brackets. Same thing for the y, but with y as a value, and let y equal 0. Actually, I turn off the linting. I don't like seeing that. And then this now is height that I'm going to be increasing it until it reaches that height, and I'll do y plus equals sample y. Okay, so nested loop, and this is basically going to visit every pixel every 50 pixels. I'm going 50 across from left to right, and then wrapping around again, starting a new row and going left to right. So that's the way that it makes sense to me, and this is a similar kind of loop to what we've been doing in our grid examples that we've built in the class. Okay, so as it moves through this, you remember how I tried to pull out the pixel data of a single pixel by giving it an index here throughout it. The index is actually calculated point by point as it moves through this, and here's a bit of code that'll do this, and I'm just going to copy and paste it from my earlier example that I did and then explain it here. So within this loop, so this is now the drawing window of this particular nested loop. This is doing a couple things right here. So this is saying is picking an index, and it's a value of where we are at this point, x plus y. So we've been moving our way left to right along, moving through the raster of that image, the matrix of that image, the stack of bricks of those pixels, and we're moving until we get to the image width, which is that size, and that's when we wrap around to that side. Multiplying it times 4 is, we're doing that because each of these pixels has 4 elements in it, so it has 4 pieces of information at each of these. I know this is getting kind of weird, but what this will do is let us actually then say, okay, now that I know what the index is, this is how you calculate the index of the particular pixel we're at right now within the pixel data, right? So the pixel data is actually this very long thing, which isn't organized. It's just like a list of numbers. So this is telling us where within that list of numbers am I able to look at the window of data that relates to the pixel that I've just sampled with the eyedropper. So X and Y is the position of the eyedropper. And now that I'm there, what do I do? What do I have while I'm there? And this is what I have. So the index lets me go back into the pixels of the big image. I know this is all sort of abstract, but hang on here. This will get, I'm about to get something here. So if I wanted, so the way this is organized, then the data that's in here is actually the R, the G, the B, and the A value of each of these pixels. So the R is the red, G is green, B is blue, A is alpha, and I just want the RGB. I don't need the alpha, so I'm just going to be dealing with those right here. And that means, so pull the pixels at our index value, just right at the index value, right where we are. That's the R. Then if I want to get the green, I look ahead to the next number in that. And then if I want to get, sorry, I'm just copying and pasting from what I did earlier. Get the B, so it's 2 numbers ahead of that one in there. So now at this point I have R, G, and B of a pixel. So the RGB, that's all I really need in order to do any kind of drawing that I want to do, right? Because if I want to draw something like, let's say, a square, and this I'm basically going to reconstruct the Pixelator example. So if you want to draw a square, you're going to have to fill it with some color. I've got R, G, and B already in memory right here because I just created those variables, and I can now, I can draw a square shape using the rect feature. I'm at rect X and Y. That's where I am along my grid, right? And I want it to be the width of my sample, because that's how far I'm jumping every time, and then the height also of my sample. So that's how far down I jump when I get to the end. And yeah, so this should make a series of pixels 50 by, well, not pixels, but representations of pixels 50 by 50 using the color of whatever pixel was sampled at the top left of that new pixel. So I know it's all very abstract until you actually see it, but let's find out if this works. And yeah, there we go. So that works. That is an interesting representation of what we had before. You notice there are still the lines on the different squares on the edges of the squares. I can always turn that off if I don't care for that, just using no stroke. So I'll go ahead and turn that off just to see that. And yeah, I kind of like that. I mean, I think it's a pretty interesting piece of art on its own. If I want to make this see as differently, I can always increase the size of my sample X and sample Y, which is going to kind of jump me along at a higher rate. And now, okay, that's obviously not as, not as easy to tell what that was to begin with. But if I go down to 10 by 10, maybe that's a little bit too close to the original and maybe not as interesting from an artistic standpoint. Okay, so if you are a student in my class and you are completing this project, you kind of have everything you need now to get started. And I'll share this code, which is just kind of the starting point in I'll share it in the assignment description and in the link in the description on the YouTube video here. But in either case, this is something that you can use. But now that you've got this information, you still need to figure out what to do with this R, the G, and the B. So in this case, I've drawn rectangles, but it's always possible to draw something else. In fact, the ellipse function takes a similar set of arguments, and so that's what those look like as a series of circles. Now this is my example, so I don't want you to do this, but you could do this, or someone could do this. This looks kind of neat as just a piece of graphic art, I think. If we made these circles instead of squares, that's already something kind of interesting and kind of different. But there's a lot more you could do with that R, the G, and the B, and a point in space. What other kinds of thing could you draw there? I mentioned several possibilities in the assignment description, like what about emoji? Or what about text? what kind of word would correspond to this color in the top left, for example. I don't know. Maybe you could think of something. And yeah, maybe I'm using Optimus Prime here, maybe names of Transformers. I don't really know. Whatever you want to do. Okay, so that's a pretty quick tutorial or demo, I guess, of working through and building up a pixel sampler that will then give you the data that you can use to re-represent those pixels in some interesting way, hopefully. So that's something you can use to make all kinds of interesting projects like the examples I showed earlier, and maybe those are inspirational for you as well. Okay, well, I think I'll leave it here. Thanks for watching this video, and if you have any questions, please let me know. Happy coding.